Hello viewers, I'm excited to come your way again in another session in mathematics, and in this session we'll be discussing variation. The objective of the class is for me to establish what variation is all about, look at the various types of variation, and of course solve some mathematical problems that involve variation. Alright, so we'll just roll. I want you to fasten your seatbelt as we roll, and of course we get to comprehensively cover the topic variation as far as mathematics is concerned. Alright, so variation can be defined as the relation that exists between two or more variables. The variables in this case can also be quantities. Okay, so variation is the relationship that can exist between two or more variables. That is, in comparing two or more variables, what can we say? Is the relationship direct? Hence we have direct variation. Is the relationship indirect? Then we have indirect variation, which is also called the inverse variation. Is the relationship joint? Then we have joint variation that has to do with either two direct, two indirect, one direct with one inverse, and the rest. And of course we also have what is called the partial variation. So in a nutshell, variation of course will help us establish a relationship that can exist between two or more variables. Now on the screen you can see the various types of variation that we have. The first one being the direct variation, second one being the indirect variation, third one being the joint variation, and of course the partial variation. Alright, so we'll just take the first one, which is the direct variation, and I'll try to establish what direct variation is all about. Alright, now for direct variation, a quantity say x can vary directly as another quantity say y. Now what you have to take note of direct variation is that anytime a particular quantity varies directly as another quantity, increase in that quantity leads to a corresponding increase in the other quantity at the same rate, and also a decrease in that quantity will automatically also lead to a decrease in the other quantity at the same rate also. Alright, so if x varies directly as y, it is expressed like this. It is expressed like this. Okay, we have x varies directly as y. X varies directly as y. Now look at the two quantities there, the two variables x and y. Now what you have in between them is what we call the sign of variation. We call this the sign of variation. Alright, so anytime you see that symbol alpha, is a Greek alphabet, alright, we call that the sign of variation. So if x varies directly as y, then it's written as this: x varies directly as y, as you can see on the screen. That is direct variation. Now in mathematics we cannot solve variation with that sign of variation. We always have to remove it. And how do we remove it? By introducing the equality sign and also a constant. Alright, so if a question says that x varies directly as y, okay, what this means is that x is equals to ky. You cannot solve with that sign of variation. You must always remove it, and removing it entails that you are going to introduce the equality sign and of course any arbitrary constant. Alright, so here where k is equals to a constant. That's how to remove that sign of variation, by introducing the equality sign and also a constant. Now that is that for direct variation. I'll quickly take an example. Assuming that a quantity x varies directly as another quantity y, so we write it like this: x varies directly as y. Alright, and x is equals to 4 when y is equals to 2. So we have x is equals to 4 when y is equals to 2. Assuming we will now ask to find x when y is now equals to 8. That's a typical question. X varies directly as y and x is equals to 4 when y is equals to 2. Now we are asked to find x when y is equals to 8. Alright, so we come back to where we what I wrote here earlier: x varies directly as y. We remove that sign of variation, introduce the equality sign, and of course a constant. So we have x to be equals to ky. Now the first set of values we have here is that x is equals to 4 when y is equals to 2. So over here on the left hand side of the equation is 4 for x equals to y is 2 with k. Alright, so if we make k the subject, we divide both sides by 2 since we have 2k. Alright, so we are going to have k to be equals to 4 divided by 2, and of course k is equals to 2. Now if you get back to where we introduced the equality sign, x is equals to ky. Now that the value of k is 2, you replace it back there, so we have that x is equals to 2y. Alright, sometimes the examiner will ask you to find what we call the relationship connecting the two variables, or the law of variation. Yeah, the relationship connecting the two variables. Alright, it's for you to find the constant value, get back to where you had introduced the constant and replace it. So when we introduce the constant, we had x equals to ky. Now that we've gotten the value of k as 2, we get back to that place and we replace it. So x is equals to 2y. Alright, that is called the law connecting the variables, or the formula connecting the variables. Alright, in this question we were asked to find the value of x when y is 8. We can of course use the law connecting the variables to do that. Alright, so x is equals to 2 times y is now 8. Alright, so we have 2 times 8 and x is equals to what? 16. That will be the solution. It's as simple as that. Very simple. Now what I want you to observe is that in direct variation, an increase in any quantity leads to a corresponding increase in the other, and also a decrease in a particular variable also will lead to a corresponding decrease in the other variable. Now what you can notice here is that x started as 4 when y was 2, and at a point x increased from 2 to 8, and of course you also expect y increased from 2 to 8, and of course the final value we are now having for x is that x has also increased from 4 to 16. So in direct variation, an increase in one variable leads to a corresponding increase in the other variable, and also a decrease in one variable will lead to a corresponding decrease in the other variable. That is what direct variation is all about. We'll still get to solve some more mathematical problems involving variation in the course of the class. Alright, so we go back to our lecture notes, and the second type of variation we have is called the indirect variation. Indirect variation is also called the inverse variation, and if x varies inversely as y, it is written like this, as you can see on the screen. X varies inversely as y, so we have x varies as 1 over y. 1 over y is called inverse or reciprocal in mathematics. Anytime you take the inverse of a number, it means 1 divided by that particular number. Alright, so if x varies inversely as y, or x is inversely proportional to y, variation is also called proportion. Alright, so if x varies inversely as y, then we have what you can see on the screen, not the other one that was direct. X varies directly as y, written as this, as I pointed earlier. X varies directly as y. That is for direct variation. But for inverse variation, of course, if x varies inversely as y, we have 1 over y. And the same thing is applicable here. We cannot solve with the sign of variation. We have to remove it by introducing the equality sign and also a constant. So here we can write this as x is equals to c of 1 over y. Now my constant in this case is c, not k. You are always at liberty to choose any alphabet you want to use as your constant, but at least it should be different from the two variables we are dealing with. In this case, we're dealing with x and y, so it will not be appropriate for us to use either x or y as our constant. You can use any other alphabet. So in this case, it was c. Alright, so we can say where c is equals to a constant. Alright, so this is x equals to, of course, c can multiply 1 there, you have c all over y. So it's as if the constant is always placed where you have 1. Alright, so this is our indirect variation, which is also called the inverse variation. And a typical example can be something like, if x varies inversely as the square root of y. If x varies inversely as the square root of y, which is written like this, x varies inversely as the square root of y, square root. And maybe x is equals to 2 when y is equals to, let's say, 16 for instance. Alright, we are now asked to find x now. We are asked to find x when y is equals to maybe 64. That's an example of an indirect variation, which is also called the inverse variation. Alright, so we go ahead with the solution to that particular problem. We were told that x varies indirectly as the square root of y. X is equals to 2 when y is equals to 16. Find x when y, of course, is equals to 64. So this is x equals to, our constant is c divided by square root of y. X is equals to 2, y is equals to 16. So we bring in the first set of values. So we have x equals to 2. So the left hand side is 2. And is equals to c divided by square root of y is square root of 16. So 2 is equals to c divided by square root of 16, of course, is 4. At this point, we can cross and multiply. So c comes down. We have 2 times 4 as 8. That is the value of our constant. Now, if I go back to where I had introduced the constant, which was x is equals to c divided by square root of y, and replace the constant where I have the c there. Alright, so I have x is equals to c is 8 divided by square root of y. So at this point, that is the formula connecting the variable, or that is the law connecting the variables. I've mentioned that before. Alright, we were asked to find x when y is equals to 64. So x is equals to 8 divided by square root of 64. So x is equals to 8 divided by square root of 64 is also 8. And 8 divided by itself, of course, is 1. And that becomes the solution to that particular mathematical problem involving variation. So that's that for the first two types of variation that we have. The direct variation, where an increase in one quantity leads to a corresponding increase in the other, and also for indirect variation, where an increase in one leads to a decrease in the other, and vice versa. Alright, back to our lecture notes. The next variation we have is called the joint variation. Now, for joint variation, a particular value, a quantity, is proportional to two or more other variables or quantities. You know, direct is just x varies directly as y. It can be any other thing. P varies directly as q. Alright, and for indirect, you also have p varies indirectly as the square root of q, cube root of q, or any other thing you want to take. Or p can just vary inversely as q, or the square of q. Alright, but whenever you talk about joint variation, it has to do with one quantity varying directly with other quantities. Okay, more than two now. Alright, so we can have a particular, we can have x varies directly as y and z as this. I can have x varies directly as the square of y, and also x varies directly as the square root of z. Alright, so if I want to join the two now, it means that x varies directly as y square and root z. This is a joint variation, talking about two direct. X varies directly as y square, and x also varies directly as the square root of z. Alright, so if I want to join the two now, I have x varying directly as y square and also root z. Alright, so the other case of joint variation is when x can vary indirectly as another quantity and also indirectly again. The first one I've explained to you is for double direct. X varies directly and also x varies directly again. Alright, now for this other one, we also have x varying indirectly and also indirectly again. Alright, so what you can see on the screen is that x varies indirectly as the cube root of p, and also x varies indirectly as the square of q. Alright, so if I want to combine both of them now, I have x varying indirectly as the cube root of p and also the square of q. That is a case of inverse variation for joint variation. That's two inverse variation being joined together. So joint variation has to do with one variable varying indirectly or inversely or both with some other variables. Alright, so this is a case of a combined one, where x varies directly as maybe the square root of y, and also x varies inversely as maybe the fourth root of k. Now this is a case of one direct and the second one being indirect. One direct, the second one being indirect. It's still joined if I want to combine it now. So I have that x varies directly as the square root of q and also inversely as the fourth root of k. Alright, so this is what we call joint variation. and of course I would love to take an example. So assuming we have something like x varies directly as the square root of y, the last thing I said, and x varies indirectly as the fourth root of let's say k. So if we combine these two now, we are going to have x varying directly as the square root of y and inversely as the fourth root of k. Now assuming that x is equals to 1 when y is equals to 4 and k is equals to let's say 16 for instance. Let's assume that we are asked to find x when y is equals to 36 and of course k is equals to 81, assuming that's what we are asked to find. Alright, so we have x varying directly as the square root of y and also inversely as the fourth root of k. We introduce a constant c. So this is x is equals to c square root of y divided by fourth root of k. Now we now substitute the first set of values we have. X is equals to 1, y is equals to 4, and of course k is equals to 16. Okay, so I have that x is 1 is equals to c square root of 4, y is square root of 4 now, square root of y, so we have square root of 4 since y is 4, divided by fourth root of 16. Alright, so this implies that we have 1 is equals to square root of 4 is 2 times c is 2c there, divided by fourth root of 16. Fourth root of 16 means a number that if you multiply 4 times you have 16, which is 2. So fourth root of 16 is 2 because 2 times 2 times 2 times 2 will give us 16. Alright, so we have 2 here. Alright, so at this point maybe we can cross and multiply, or we can just use the 2 we have on the right hand side to cancel each other. So 2 is up here and 2 is down here, we can cancel. So what we have left here is that c is equals to 1. That's the value for our constant. So if we go back to where we had introduced the constant, which was x is equals to c square root of y divided by fourth root of k. Now if I go back there and I replace c as 1, so I'm just going to have x is equals to, we don't need to write the 1. Since the coefficient is 1, we just keep it like that. So we are left with square root of y divided by fourth root of k. Now of course this is our formula connecting the variables. That is the law of variation. Sometimes in the exams, the examiner too, of course, can ask you to find the formula connecting the variables. That is that. Alright, the second part of the question, we're asked to find the value of x when y is equals to 36 and k is equals to 81. Okay, so we have that the formula that is connecting the variables is x is equals to square root of y divided by fourth root of k. Now y is now equals to 36 and of course k is now equals to 81. We are asked to find the value for x. Alright, so we have that x is equals to square root of 36 now, since y is now 36, divided by fourth root of 81. So x is equals to square root of 36 will give us 6. Okay, divided by fourth root of 81 means a number that if we multiply, of course, 4 times, we have 81. Now 81 is actually 9 times 9 and 9 is 3 times 3. This one is also 3 times 3. Alright, that means 81 contains 3 in 4 places. So fourth root of 81 will give us 3 because 3 multiplied 4 times will give us 81. Alright, so fourth root of 81 under there is 3. Alright, so 3 here is 1 into 6 is 2. 2 over 1, of course, our x is equals to 2. That becomes the solution to that particular problem. Very simple, very simple. Variation is actually one of the simplest topics you ever come across as far as mathematics is concerned. And of course, finally, the last type of variation we have is called the partial variation. Now in partial variation, a particular variable varies partly to another constant and also partly to another variable. So in partial variation, it deals with, as you can see on the screen, it deals with a quantity that depends on another independent quantity, where one of the independent variables remains the same, okay, and the other changes according to the quantity of the independent variable used. All right, in case you don't really grab what that English is talking about, this is what we mean. If a quantity, let's say x is partly constant and partly varies as the square of y, x is partly constant and partly varies as the square of y. This is how we interpret that. X is partly constant, so we write x is equals to a constant, and partly varies as the square of y, where k and c are constants. In partial variation, you have two constants. Okay, so you see a question like x is partly constant, so you write x is equals to a constant before you now join the second guy, which can be direct or indirect. So x is partly constant and varies directly as the square of y, what you can see on the screen, or x is partly constant and varies inversely as the square of y. So that would have given us something like this. Inversely now, c over y squared. The first one was direct. So x is partly constant and varies directly as the square of y. In partial variation, you have two constants. Alright, and your first set of values will also be two values, because since you have two constants, in variation you must always find the constants. Okay, so here we are finding two constants. That means we'll be dealing with a simultaneous equation, which of course you can substitute or use the elimination method. Anytime you are dealing with partial variation, the first set of values will be 2 each for each variable, that's x and y, so that you will be able to form. This is what I mean. Now if x is partly constant and partly varies directly as the square of y, like you can see on the screen, x is equals to a constant. When they say partly constant, so it's equals to a constant, plus directly as the square of y, you introduce another constant before you write the other variable, which is the square of y. So you have something like x is equals to 2 when y is equals to, let's say, minus 1, negative 1, and also x is equals to 3 when y is equals to, let's say, 2. Now you'll be asked to find the formula connecting the variable, or maybe find x when y is now equals to this. Based on your first set of values, you'll be given two values for x and also for y, because you are dealing with two constants and you should have a simultaneous equation. So here we are going to have something like x is equals to k plus c y squared. The first set of values, 2 for x and negative 1 for y. So we have 2 is equals to k plus y squared is minus 1 squared, which will still give us 1. So we have k plus c. We call this equation 1. And the second set of value, y is equals to 3, and this is equals to k plus cy squared. Y here is 2, so 2 squared, of course, will give us 4. So 4 times c there will be 4c. We call this equation 2. So in partial variation, of course, you are always dealing with two constants, as you can see on the screen, k and c, and you always have a pair of the values given for the variable so that you can solve it simultaneously. Alright, so if we quickly solve this, we can quickly say equation 2 minus equation 1. So left hand side, 3 minus 2 will give us 1. I'm using elimination method now. Now k minus k is gone, and 4c minus c will give us 3c. And if we make c the subject, we have 1 all over 3. That's the value for that constant c. We can substitute c as 1 over 3 into any of the equations so that we can find k. Alright, so if I put c equals to 1 over 3 into equation 1, so into equation 1 now, into equation 1 we had 2 is equals to k plus c, where c is now 1 over 3, so 2 is equals to k plus 1 over 3. Alright, so if we make k the subject, we take 1 over 3 to the left hand side, so we have 2 minus 1 over 3, of course, is equals to k. And you know how we do this. Try to find LCM, which is 6. 1 into 6 is 6 times 2 is 12, minus 3 into 6 is 2. So we're having k to be equals to 12 minus 2 is 10 divided by 6. Of course, 2 here is 5, 2 here is 3, so we have 5 over 3 as the value for k. Okay, we're having the first constant to be 1 over 3, and we're having the second constant to be 5 over 3. Alright, the second constant is 5 over 3. You can make a quick review of simultaneous equation, but in these tutorial sessions, one of those topics I'll be coming your way with equations, and I shall take time to extensively talk about, of course, simultaneous equations. Alright, so here we're having x was actually equals to k plus cy squared. Okay, so our c is 1 over 3 and our k is 5 over 3. So we're having x to be equals to k is 5 over 3 plus c is 1 over 3 of y square. So this of course is going to give us x is equals to 5 over 3 plus y square all over what? 3. Since the denominators are the same, 3 and 3, we can compress it together. So here we can have x to be equals to 5 plus y square all divided by 3. Of course, that is the formula connecting the variables. Even if you want to cross and multiply 3 to this side, you have 3x is equals to 5 plus y square, still the same thing. That is our formula connecting the variables. This is how we handle partial variation. X is partly constant, so you write x is equals to a constant, and partly varies directly or it can be indirectly with some other variable. All right, so this is what we have for indirect, for partial variation. So in summary, we have some exercises, of course, where you'll be expected to find the value for a particular variable after you've finished identifying the equation as direct, indirect, joint or partial variation. All right, so I'll keep the first 2 exercises for you because they are simple. One says that given that x varies directly as y, you know how to write that x varies directly as y, and x is equals to 4 when y is equals to 2, find x when y is equals to 16. That's a direct variation, and of course y increases from 2 to 16, so you also expect x to increase from 4 to something more than 4. And for the second one, you have I would love to see your solution. You can put your answers in the comment section. I'll take a review of it. Now the second exercise you have there is that if p varies indirectly as the square root of q, p varies indirectly as the square root of q, I'm sure you know how to interpret that, and p is equals to 1 when q is equals to 9, find p when q is equals to 36. These are very simple questions which I'm sure you can handle it. Alright, I'll take time to explain the last question. I'll take it myself so we can solve it together. Alright, this is a case of a joint variation, and what we have is that a force F needed to stop a car varies directly as its weight and also the square root of the velocity, and inversely as the distance of the distance traveled. Alright, when F is equals to 36 Newton because it's force, I'm sure some of you that are science students, you know the unit for these quantities. Force is 36 Newton, our weight of the car is 120 kg, and of course the velocity of the car is 100 km per second when the distance is 50 km. We are asked to find the formula connecting the variables. I've been saying this in this current session. How to find the formula connecting the variable is just to find the value of the constant you had introduced when you remove the sign of variation and going back there to replace it. And also we are asked to find the force required for a car traveling at a velocity of 256 km per second with a weight of 200 kg after it has covered a distance of 800 km. Alright, so let's take this again and solve it. The force F needed to stop a car varies directly as its weight and the square root of the velocity, and inversely as the distance traveled. Now it varies directly as the weight of the car and the square root of the velocity, and inversely as the distance traveled. Alright, so we have F, which is used to represent force in this context. So F varies directly as the weight of the car and also the square root of the velocity, and of course inversely as the distance traveled. Now a quantity F is varying directly as the weight W, is also varying directly as the square root of the velocity, and is also varying inversely as the distance traveled. So this is a joint variation, and this one of course involves 2 direct and also 1 indirect. Okay, so that's the interpretation to this. So we can remove this sign of variation by introducing the constant. So we have M is equals to K, W for the weight, square root of V for velocity divided by the distance traveled, which is G. And the first set of values we had was that our force F is 36, weight is 120 kilogram, velocity is 100 km per second, and distance is 50. 36, 120, 100, and of course 50, as you can see on your screen. Alright, so our force here is 36, Our force here is 36 Newton. Our weight is 120 kg. Our velocity is 100 kilometer per second, and of course the distance travel is 50 kilometer. All right, we fix all of them over here. So we have F is 36 is equals to K times W is 120 times square root of V, velocity is 100, divided by the distance travel, of course, is 50. Okay, so we have that 36 is equals to K multiplied by 120 multiplied by square root of 100 is 10, divided by what? 50. Now we can cancel this. 0 can cancel 0 here. All right, 5 here is 1 into 12 is 2, which is 10. That's 2, which is 10, remainder 2, into 20 is 4. All right, so what we have here is that 36 is equals to, you can use your calculator if you want to, 36 is equals to what we have left on the right hand side is K and also 24. Okay, so we have 24K, and if we make K the subject, we have 36 divided by 24. All right, we can use 6 here to cancel. 6 into 36 is 6, into 24 is 4. 3 here is 2 here rather is 3, and of course 3 here is 3. 2 into 6 is 3, sorry, and 2 into 4 here is 2. All right, so what we have as our constant is 3 divided by 2. That is the value for the constant. We were asked to find the formula connecting the variables. All right, so we have something like this. What we had was F to be equals to K W square root of V divided by D. All right, so since our K is 3 divided by 2, so we have F to be equals to 3 divided by 2 for K, then W square root of V all divided by D. All right, that is the formula connecting the variable. Since we have 3 over 2 on top, of course you can always bring the 2 down. It's mathematically consistent, so we can write this as F is equals to 3W square root of V divided by 2D. All right, this is our formula connecting the variables. Very simple. You just find the value of the constant, go back to where you introduce the constant, and you replace it again. All right, the second part of the question, as you can see on the screen, we were asked to find the force F for a velocity of 256 km per hour, weight of 200, and a distance of 800 km. All right, we are asked to find F when the velocity is 256 km per hour. The weight, I think, is 200. Let me confirm that. Okay, our weight is 200, is correct. What again? Distance that is covered, of course, is given as 800 km. All right, so we fix this up. We have F is equals to 3 times weight is 200 times square root of the velocity is 256 divided by 2 times D, which is distance is 800. You can see it on the screen. All right, so we have F is equals to 3 times 200 times square root of 256, of course, is 16, divided by 2 times 800. All right, now when you get over to this point, you are in the examination, or sometimes you are not with a calculator, you can easily, of course, find your way here. Now for 800 and 200, we have 2 zeros we can use to cancel. So these 2 zeros on top can cancel the 2 zeros below. All right, that's mathematically true. Of course, this 2 here can also cancel this 2 here. 2 on top, 2 below, they can cancel. 8 here is 1, into 16 is 2. Of course, what we are left with is 3 times 2 at the numerator, which is 6. So our force F is equals to 6 Newton. That is the force. All right, ladies and gentlemen, that has been our session as far as variation is concerned. And of course, in summary, in this session, I have established what variation is all about as a relationship that can exist between 2 or more variables. Also, I have established the different types of variation that we have. Direct variation, where increase in one will lead to increase in the other, and also decrease in one variable will lead to a corresponding decrease in the other at the same rate. Also, I've established the inverse variation, which is increase in one leading to a decrease in the other, and decrease in one leading to an increase in the other variable. And of course, the joint variation, where a quantity S can vary directly as 2 other quantities, or indirectly as two other quantities and one direct or indirect. And of course, I've showed you what partial variation is all about. Till I come your way again in another session where I'll take another topic, don't miss this particular. All right, bye.